All right, so we're going to introduce square roots and cube roots today. So let's start with some basic definitions. Before we can even talk about square roots, we need to make sure we understand what we're saying when we say something is squared. So it comes from, or it's related to geometry. So if we have a square that's, say, a length of 3, then we know that the area inside is 3 times 3, or 3 squared. So for any number, if we're saying, what's this number squared, another way of saying it is, what's that number to the second power, or what's that number times itself. But if we want to be able to go the opposite direction, say we know what the area is, but we want to find the side length, then we need something new. And the reason we need something new, so if you think about it, you've obviously worked with adding and subtracting forever, multiplying and dividing forever, and you know that each of those things is related to the other one. So adding and subtracting are related. Subtraction helps you find a missing piece in addition. Dividing helps you find a missing piece in multiplying. Well, we need something new for exponents. So we need something that answers the question of, what number squared gets us another number. So in this case, we're looking for what number squared gets us 25. And how we find that number is we take what's called the square root. And this symbol right here, I know it looks a little bit like division. It's not division. It's not the division sign. Is the square root sign. So if we have this right here, we're looking for the square root of 25. So how you find it is you just have to ask yourself, all right, what number squared is going to be 25? And you really just have to, at first, go through the list. Let's see, is it 1 squared? Well, that's 1 times 1. No. Is it 2 squared? 2 times 2 is 4. No. 3 times 3 is 9. No. 4 times 4 is 16. No. Oh, but 5 times 5, that's 5 squared. That would get us 25. That means that the square root of 25 is 5. So again, if we were looking for, let's say, 49, all right, the square root of 49, we go through our list, mentally or on paper, on a whiteboard, whatever, and you figure out that it's 7, because 7 squared is 49. So the square root of 49 is 7. That's how these two things are related to each other. All right, along with it, we also have something called a cube root. So again, just to backtrack, a number cubed, so for example, this is a cube. It has, it's 4 blocks long, we can see, so we're going to say that it has a side length of 4, and it's the same all the way around. So in geometry, we'd be finding the volume, and it would be by doing 4 cubed, 4 times 4 times 4. In this case, it would tell us how many blocks are in this cube. But it's really the same thing as just doing 4 to the 3rd power, because that's 4 times 4 times 4. Now, you might need a calculator for that. That's fine. 4 times 4 is 16, times 4 gets you 64. But we really have this same problem we had before, which is we want to know a way to undo it. And it's really pretty similar. So instead of a square root, we also have something called a cubed root. And it's written just like this, again, just like the square root before, except there's a little 3 in the corner. Again, it's not division, it's the cube root. So the cubed root of 64 is the number that when you cube it, gets you 64. So 4 times 4 times 4 is 64, and so the cubed root of 64 is 4. And again, if we're looking for another one, the cubed root of 125. So again, if this this thing had 125 blocks and we wanted to know how long the side was, we're still doing the same thing, really the same sort of process we did for square roots. We just have to go through our list and say, all right, well, 1 times 1 times 1, 1 cubed, that's just 1. 2 cubed, well, that's 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. 3 cubed, 3 times 3 times 3 is 27. 4 cubed, we know, is 64. 5 times 5 is 25. Times 5, again, gets us 125. So 5 cubed is 125. And so the cubed root of 125 is, oops, sorry, that was my mistake there. The cubed root of 125 is 5.